today we are starting the last section of Chapter 1. Today is the last section of Chapter 1. Now the first thing we're going to look at is supplementary and complementary angles. Now two angles are considered supplementary if they add together to be 180. So if I can take two angles and add them together to be 180, they are considered to be supplementary angles. Complementary angles add up to be 90. Let's play with that later. Supplementary angles add up to be 180 degrees. Complementary angles add up to be 90. Thank you. Yep. Complementary angles add up to be 90. Supplementary angles add up to be 180 degrees. So if two angles add together to be 90, then they're considered to be complementary. If two angles add together to be 180, then they are supplementary. Any questions on this here? Okay.
So what you're saying is past 180 is supplementary, and before 90 is, or past 90 is supplementary.
Well, if one of them's 47 and the other is 43, 47 plus 43 is?
Yeah.
90, so they are complementary. If we have two that add up to be 180, then they are adjacent angles is the other part we're getting down here. Now, you don't have to write the whole thing. Complementary and supplementary angles can be adjacent angles or non-adjacent angles. Adjacent angles are two angles that share a common vertex and common side, but have no common interior points. So two angles are considered to be adjacent if they share a common angle or common vertex, common side, and no common interior angles. Common vertex and side, no common interior points. That's just saying one cannot be inside the other. One angle cannot be inside the other angle. So if one angle is contained within the other, they're not adjacent. Mm-hmm. Nope. Any questions on adjacent angles so far? Okay. But the main points I would get for this here is common vertex and side, but no common interior points is the main thing about adjacent. So we're going to do three things on this first one. We're going to name three things. The first is we're going to name complementary angles, name a pair of complementary angles, name a pair of supplementary angles, and name a pair of adjacent angles. So the first thing we're looking at is two complementary angles. Well, complementary angles do what? Okay, so we need two angles that add together to be 90 degrees. So what two angles in this here add up to be 90? So F, G, K, and LKG. Because we have 49 and 41. 49 plus 41 does give us 90 degrees. So those would be not complementary. That would be, yeah, that's complementary. Now which?
Exactly.
They have to be exactly 90 degrees. If they're complementary angles, they add up to be exactly 90 degrees. Supplementary add up to be what? 180. Complementary is 180. Complementary is 90. Supplementary is 180. So which two angles add together to be 180 degrees? I would say GKL, yes. And HGK or KGH, because 49 and 131 would add together to be 180. Because these two here add together to be 90. And 131 and 149, 0 carry the 1, and we get 180. So it'd be those two together. Okay. Any questions on complementary or supplementary, or how we got these angles, or figure these out? Now the last one is adjacent. So we want two adjacent angles. So adjacent angles do what, or what describes adjacent angles? So they have a common vertex and common side. So what would be a common vertex where we have more than one angle? G. And our common side would be? DK, this here. So what two angles? FGK and angle HGK. Because L would be down here. So, and it wouldn't share a common vertex. It would share a common side, but not a common vertex. So that would be it. Now we couldn't do FGH. FGH, erase this. FGH and FGL, because all the points in FGK, all those points in there would also be contained in the bigger angle. That's what it means by no common interior points. Yes, sir. For which two? So, which angles are you talking about? With what and what? Guys, let's focus up here. So what would be the whole angle that you're asking about? Are we talking about angle FGK, FGH, like what angle? Because this has a common side, but we need the angle whose sides it does share. FGK and what? FG. Well, if we have this, they have a common vertex and a common side, yes? Are all the points in here also shared in the bigger one? Well, those overlap, don't they? For it to be adjacent, they can have what? No common. So since these share all these points here in both angles, those would not be adjacent. Those would not work. If we have two adjacent angles, they cannot be contained in each other. One cannot be inside the other for them to be adjacent. Questions on this here? Let's look at this next part here. are angles KGH, angle KGH, and angle LKG adjacent. So KGH and
GK and GKL are.
well, are these two adjacent to each other? Well, possibly, but well, that's not what it's asking. Tyler, guys, Tyler, let's focus. So, do these have a common vertex? Do these two angles have a common vertex? So what's the vertex for KGH? G. Vertex for LKG is? So if they're adjacent, they have to have a common, well, these do not, so they are not adjacent. Because they have to have a common vertex and a common side and no common interior points. Those are not. FGK and angle FGH. Any other questions about angles KGH and angle LKG not being adjacent? So let's look at the next one. So FGK and FGH. Do these two angles have a common vertex? So G and G, they do have a common vertex. Do they have a common side? So F, well, different one. Yeah, so FGH, FGK. Well, the common side is F to G, yes? So they have a common vertex, common side. Was there anything else about adjacent angles? Can't have any interior points in common, yes? So FGH is all of this here, yes? And FGK is all of this here. Do those overlap? So are they adjacent? No. Since they have common interior points, they are not adjacent. Any questions on this here? Let's look at the next part. In the figure, name a pair of complementary angles, supplementary angles, and adjacent angles. So can someone give me a pair of complementary angles? Complementary does what? 90, adds up to 90. So which two angles add up to be 90 degrees? CAB.
RST.
And angle.
CAB.
So we could have said BAC or CAB and RST or TSR or just angle S. But those two would add up to be 90. 53 and 37 would add up together to be 90 degrees. So it makes them complementary angles. And that is it. How about supplementary angles?
127 and
So we'd have RST again. And our other angle would be what? CAD.
4.
So those are our complementary and supplementary. Complementary adds up to be 90. Supplementary adds up to be 180. Now, which angles would be adjacent?
RST.
CA, CAB, and DAC. Because those two do share a common vertex, point a common side of CA, and they do not have any common interior points. Thank you. Any other questions on one of these three here? We feel good with these?
Yeah.
All right. Okay. Okay. Let's look at this one here. Angle 1 is a complement of angle 2. Well, what does that tell me? Which means it's up to 90 degrees. So that's saying that angle 1 plus angle 2 is equal to 90, yes? Okay, what else does it tell us? And the measure of angle 1 is? So we're really saying that 62 degrees plus angle 2 is? Well, what do I need to do? So we're just saying that angle 2 is 38 degrees. 28. 28. 28. 2. Any questions on this here? So really, what did we do? We just subtracted 62 from 90. We ready for the next one? Angle 3 is a supplement of angle 4. Well, what does that mean? They add up to be 180, yes? And we're told one of them is? So what can we do to solve for the other angle? We can take 180 and subtract what? So really, we can just subtract 47 from 180 and we get the answer. Because we could do the same thing we did on the first one. Angle 3 plus angle 4 is equal to 180. Replace angle 4 with 47, subtract it from both sides. And we see that the measure of angle 3 is 133 degrees. Or we can just say 180 minus 47 and get 133.
I like this.
How about this one here? Angle 1 is a complement of angle 2, so what do they do? They add together to be? Right, so we'll do 90 minus. So the measure of angle 1 is 85 degrees.
I say just put this on our test.
Where could I watch
Hmm?
Is there somewhere I can watch that?
Brit TV.
Is it on Netflix?
I don't think there's probably some, but not a lot.
Tyler, we all like about
Any questions on this here? All right, we got one more of these. So they tell us that these two angles are supplementary, so they add together to be 180. We're told one of them is 148, so we can take 180 and subtract what from it? So the measure of angle 4 is 32 degrees. And that's it. Questions on this here? When viewed from the side, the frame of a ball return net forms a pair of supplementary angles with the ground. Find the measure of each angle. Well, if they're supplementary angles, what do? They add together to be 180, yes? So it's saying that 4x plus 8 If we add it together with x plus 2, these will equal 180. Because that's what supplementary angles are. They add together to be 180. So that means now I can just combine like terms to find the value of x, or solve for the value of x. Plug it back in and we'd get the angle. So 4x and x would add together to be 5x. 8 and 2 would add together to be is equal to I would subtract 10. Let's do addition and subtraction first. Because those would cancel, leaving us with 5x is equal to 170. And then what would we do next? Divide by 5. Which tells us x is equal to yes. So are we done with this problem here? What did it ask for? Measure of B, C, E, and E, C, D. We have to plug it back in. So we can take 4x plus 8, and we'll plug in 34. Now at this point here, since that's just straight numbers, 4 times 34 plus 8, we can type it into the calculator and it do it for us. If we did this here, 4 and 4 is 6, carry the 1. 4 times 3 is 12, plus 1 is, and we get 144 degrees for the measure of angle BCE. We can do that, yes. But what's the other one? Well, the other equation was x plus 2. 36. And these two do add together to be 180, yes? So doing the subtraction from 180 does work. It does give us the correct answers here. But I would just be careful and just kind of plug them into the calculator just to be sure and double check. Because if, for some reason, I said 148, I put down the wrong number for this one here. If I subtract it from 180, I wouldn't get 36, I would get 32. So 148 and 32 would add together to be 180, yes? But if I plug it in the other one and see, okay, well, that's not the right number, then we can fix it. Does that make sense? So if we subtracted it from 180, it will give us a number that would add together to be 180, but it may or may not be the right answer. Yep. Any questions on this here? Do we need to see another example of this here with complementary angles? Okay. We good? Awesome. And that last main thing we're going to talk about is linear pairs and vertical angles. So I'm going to show this here. If you want to write all this down, I'll give you time later. But the main thing with linear pairs, and I'll point this out, is that they have, so it talks about them having the non-common sides or opposite A's, and the angles in a linear pair form complementary angles. Well, when we look at this picture, what do the two angles make? A line, yes? If two angles make a straight line, then they are a linear pair. Well, linear, what's the first 4 letters in linear? Line. It's two angles that make a line. That's a linear pair. Our vertical angles form two pairs of opposite rays, essentially where two lines cross. Because if two lines cross, they can kind of mirror each other over, then they are vertical angles. And we could have more, but they have this here. So let's actually look at it and see, because once we see it, it'll make a little more sense. And that definition is in the book. So the last slide is all in the book. So if you want to copy it down later. So what we want to do is we want to identify all linear pairs. So any two angles that make a straight.
Line.
So are there two angles in here that make a straight line?
Yes.
1 and 3.
Isn't there one in the middle of 1 and 3?
2 and 5.
So between 1 and 3. So this here is a straight line, yes? 1 and 3, do those add together to make a straight line?
No.
No, there's this gap in the middle, isn't there? No?
It's 4 and 5. 4 and 5.
So these here, so there's one part, there's 2, and that makes a whole line, doesn't it?
Yeah.
Yeah, so 4 and 5 do make a straight line. Now 1, 2, and 3, angles 1, 2, and 3 do make a straight line, but how many angles are there? Because 1, 2, and, guys, 1, 2, and 3 do make a straight line, but there's 3 angles, yes? But we're talking about a linear, how many are in a pair?
2.
So if it's more than 2, it would not be a linear pair. Now there is another set here. What?
2 and 5.
Well, 2 goes from here to here. 5 goes from here to here to make this straight line. 1 and 4 do. Because these also add up to be 180. Because 1 and 4 are right next to each other. They are adjacent and they make a straight line. So they would be a linear pair. Any other questions on linear pair? Now the other one is vertical angles. Now vertical angles are where two lines cross and their sides make opposite rays. Well, if we look at this here, this line and this line here do cross. So the angles contained between them will be vertical angles. So that would be what? Angle 1 and 5. Now 4 would have a vertical angle if it wasn't for this extra line here. Because 2 and 5 would not work because 2 and 5 wouldn't work because we need two pairs of opposite rays. So this here is part of 2 and it would form an opposite ray, yes? The other side of 2 goes this direction and its opposite ray is not here. So that's what's preventing us from having another one. Now if this one ray that split 2 and 3 wasn't here, then those two would be opposite or vertical angles. Because if this was just an angle, if this was just one angle here, 2 and 3 was 1, then it and 4 would be vertical angles. But because of that ray split it into 2 and 3, it doesn't work. Huh? It has to make an X. Questions on this here? Because we'll look at, I want to skip that one and go to 6. I want to look at this here, these vertical angles in linear pairs. Linear pairs. So which two angles make a linear pair? Yeah. Because none of these two angles make a straight line. Because we need 3 to make a straight line. So this does not work no matter how we set it up. So this here does not have any linear pairs. But there are several vertical angles.
1 and 5.
So 1 would have 1. It's 1 and what? 1 and 4. Because if we looked at this here, and let me get some colors. Because this is one side of 1, and the other side of 1 is here. So the opposite, so our opposite rays going extending out would contain those two, yes? Opposite, opposite, so 1's in the middle, 4's in the middle. Let's get another color. Let's go with the light blue. So 3 will have 1 and 6. Because if you notice, if they are there, they're almost right across from each other. They're going straight across. So, let's look at this here, because 6 and 3, 2 and 5, so they're almost going straight across from each other. Straight across. Any other questions on this here?
Anna Marie, come to the office. Anna Marie,
Okay.
come to the office.
This here's the last thing we're going to talk about. I know I skipped a few. I did that on purpose. This here's the last thing we're going to talk about. Now, there's some things that we can know for sure. Some things we can assume or we can conclude. Looking at this picture here, all points in it are coplanar. So from here on out, if there are points shown on a plane without a plane actually drawn in, they're all going to be coplanar, no matter where they're at. Points A, B, C, and D are collinear. They're on a line, so we're going to say that they are collinear. We can conclude that, and that B is between A and C. Well, we can see that, yes? AC is a line. BD and BE are both rays, and they all intersect at point B, because that's where they all start and they all cross, yes? Okay. BDE and EBC are adjacent angles. DBE, EBC are adjacent angles because they share a common vertex and a common side and no common interior angles. And lastly, point E is in the interior of angle BDC. BDC. It's inside it. However, we cannot conclude that AB and BC are congruent. Because in that original picture, they did not tell us. Because if it's not told to us, we can't assume it's true. We cannot assume that BDE or DBE and EBC are congruent. Because again, in that original picture, it didn't tell us. It has to tell us that. And we can't assume that angle DBA is a right angle unless it is told to us. So unless we know it or can show it or prove it, we cannot assume it to be true. We have to be able to show it. And once we get theorems and postulates that actually give us the proofs, then we can start using them and not having to show them every time. Because once we can show it's true once, that's all we need. And that is it. That is all we are covering in Chapter 1. Yes, make sure you get the assignment down.
Yes. Cut out ready.